So we're doing the video for the Algebra 2 Trigonometry Review, Day 2, and we will do the examples that I have here, hopefully with some help. Then we will do a 6 problem, a little time, and then we'll move on from there. So this says find the value of x and round to the nearest tenth. And I look at these and I see I have triangles, and I see that they've given me an angle. So what that means is I need to do some thinking about SOHCAHTOA. And we are supposed to find this information to the nearest tenth. So just like we did 2 days ago, we want to say, what should I circle? You have to use an angle that they give you that's not the 90 degree acute angle, and they only gave us this one, 33. Now if you're saying, well, I could get the other one because every angle is 180 degrees, I could subtract 90 and then subtract 33. Don't do that, because what if you make a mistake? Use the information that they are giving you so that you don't mess up accidentally. Now what I have to do is remember my sides of opposite, adjacent, and hypotenuse. Which label should I give the 14? That's the hypotenuse. Which label should I give the x? Look at where it is. Opposite, across from. Remember, as far away as you can get from that 33-degree angle, that's the opposite. Now also notice I'm not labeling adjacent because it doesn't have any numbers, so it's not going to help me. So I look at this and I see my labels are opposite and hypotenuse, and I think SOHCAHTOA, oh, I need to use sine. So the sine of 33 degrees equals x over 14. I want to remind everybody, the sine of 33 degrees is just a number. It's stored in your calculator. So even though that doesn't look like a number, we treat it like a number, and we say, well, if I'm going to get x by itself, I need to multiply both sides by 14. So 14 sine of 33 degrees is going to give me x. So we're just going to go ahead and punch that in now that we have our calculator set to degrees. 14 sine of 33 and they said round to the nearest tenth. Getting 7.6? Good. 7.6 it is. Now I'd be looking around for a label. But they didn't label anything. And it wasn't a word problem, so we can't go back and see what the label is. If you really want to put a label on there, usually if they don't give us a label, we don't bother with it. It's just one of those things, if it's an word problem, make sure we have those labels. So let's look at number 2. What are we going to go? 37 degrees. That's the one they gave us. What should we label the 14? Hypotenuse. Remember, it's right across, opposite of the 90-degree angle. So there's hypotenuse. How about x? This is adjacent this time. Remember, opposite is not even touching the angle. It would be the opposite side right here because it's not even touching the 37 degrees. So this would be adjacent. Now I think about my SOHCAHTOA. I know I have adjacent and hypotenuse labeled there. Which trig function should I use? Cosine. Cosine of 37 degrees equals adjacent over hypotenuse. That looks very similar to the last one we had. So how would we solve it? Yeah, multiply both sides by 14. 14 cosine of 37 degrees equals x. I'm going to let you pop that in, and we want to round to the near tenth. Brittany says 11.2. Is that what everybody's getting? Beautiful. So if you're thinking, boy, this really seems familiar, Yeah, you did this in geometry. Oh. Alrighty, so let's go to number 3. So which angle are you circling? What are you going to label the 6? Opposite. How about the X? Adjacent. SOHCAHTOA. Which one? All right, so the tangent of 68 degrees equals opposite over adjacent, and things got a little weird, right? Because you can't solve for a variable that's in the denominator. Can't do that. So the first thing we have to do is get it out of the denominator, get it out of the basement. We're going to have to multiply both sides by x. Divide by the tangent of 68. Again, we have to remember it's just a number. It's stored in our calculator. So if we punch in 6 divided by the tangent of 68 degrees, we should be able to so punch it in. Let's see what it is. 2.4. So sometimes there are ones again on top, and then all we have to get our answers. Sometimes our variable is on the bottom, so our first step is to multiply the variable to get it out of the denominator to solve. This is more like what we're going to see on the MCAs and the ACTs. They give what we did on the last page. So we have an escalator. Escalators look something like that at a shopping center. And it is 200 feet, 9 inches long, which is a problem because we have to have a symbol. But we should read the whole problem through to see what label we want to use here. And it rises. So when they're talking about rising eye level, to look at the top of this, you'd have to look up. That rising piece is right here at 15 degrees. What is the vertical rise of the escalator? Well, that is this distance right here. It is up and down. So, round to the nearest inch. There it is. What to do with that 200 feet, 9 inches. So how are we going to change 200 feet into inches? $2,400, but we won't forget to add 9. Now we've got the stuff on there for SOHCAHTOA. Pretty obviously, we're going to circle this one. Right here, there's our 15 degrees. So what do we label the X? Opposite. What do we label 2,409? SOHCAHTOA. Which one? Sine. Sine of 15 degrees equals opposite over hypotenuse. Did you solve it? Please do that. I suppose I better punch another one in on the video here. What were we supposed to write, everybody? This time, what would we put? 623 inches. So definitely expect some basic word dummy type stuff on there. So number 5, it's not an escalator anymore. Now it's a ladder. Don't argue with the problem. It says what it wants. There we go. 12-foot long ladder. Leaning against a wall. Makes a 77-degree angle with the ground. Should I put that up here? No, that doesn't make any sense. The ground is down here. There's our 77 degrees. How high does the ladder reach on the wall? Well, there's the wall right there. But no, is this inches? No, it's not. How do we get it in inches? Times it by 12. All right. What's X? Opposite. OPP. 144. Hypotenuse. HYP. Opposite and hypotenuse. So, sine again. Sine of 77 degrees equals X over 144. How are you going to solve? That's exactly what we're going to do. 144 sine of 77 degrees. Put a calculator and this onto the nearest inch. Beautiful. So a little word. Now, they don't want to sign anymore. Over there. If you didn't hear Obadiah's question, he says, is there a way to do this without a calculator? I was going to answer, well, back in the day when we were in school, we didn't have calculators, but we had tables in the back of the book. So we still had to look up engines. You need that number, and that's just something you've got to have on a little chip in your calculator or from a book. Alrighty. This one's different. Look what they're asking us to find. Yeah, that's different. So we still are going to use the SOHCAHTOA, and we're going to think back to geometry and how you use the calculator to work backwards. So this is absolutely what we want, and it says round to the nearest tenth, so we'll just kind of keep that in the back of our mind as we're doing this. But we still need to label. So what would you label the 17? It is opposite. OPP, what do you label in the 11? Adjacent. Which trig function? Tangent. So the tangent of x degrees equals 17 over 11. Does anybody remember from last year how we're going to use that calculator to work backwards to give us the angle? Obadiah, do you remember? It is the inverse. So above your sine, cosine, and tangent, you're going to see this little blue stuff that says the inverses, because it has the -1 power. That's how they signify inverses to us. So what we're going to have to do is punch in second tangent of 17/11, and that's going to give us our degrees. Better punch that one up here on the video. So second tangent, then we had 17 divided by 11, 57.1. Now, this is really important. We need to put this little bubble up here for our label, because that bubble is the degree bubble. And if you're thinking, well, why do we need to do that? Because remember, there's other ways to measure angles. In fact, there are three that just pop into my head immediately, but radians is the one that your calculator was set to, and we had to change it. And then in engineering, they use a whole nother different system to measure those angles. So they're more exact than degrees, but degrees is what's going to be on your MCAs and ACTs. Alrighty, so let's take a look at number 7. Tell me what you're doing. Talk me through this one the whole way through. Circle an X. And then label. Yeah. What'd you label the 12? Opposite. 9. Adjacent. You got a trig function in mind? Yeah, and I kind of wish they didn't use exactly the same one here, but they did. So the tangent of x degrees equals 12/29. And let's get everybody to punch that in with the inverse. And let's see if we all come up to the nearest 10th with the same thing. No, you can just sit. It's 20 nice and loud. Everybody else agreeing with that? All right, 22.5 degrees right there. So you may have noticed a little class worksheet with problems on it for you to work with chicken available partners or whoever it is you're sitting with, and then we'll go on to the next one.